Algebra 2 Honors Lesson 9.5, Adding and Subtracting Rational Expressions. All right. Now let's recall when you first learned about fractions. Let's see if we have something like 2 over 3 plus 1 over 4. In order to add or subtract, right? In order to add or subtract fractions, you need to get a common denominator. Okay, a common denominator. Right? So basically you're going to be doing the same thing, right? But with rational expressions. So you have to look to find the common denominator before you add or subtract the terms. Okay? Now, in the book, in 9.5, the common denominator they refer to as the least common multiple, alright, or LCM. Okay? So when you hear me say LCM, just think of common denominator. That's what I'm talking about. Alright? And it stands for least common multiple. Alright, so we'll start off by finding the least common multiple. Okay? So it says find the least common multiple of these two terms right here. So to find the least common multiple, or the LCM, the first thing you need to do is you need to factor, right? You need to factor. So you're going to factor this as much as you can, and as always, alright, when you're factoring, you always look for a GCF first. So anytime you're factoring, look for a GCF. So this looks like it has 4 as a GCF. So then that'll give you x squared minus 9. And then this is the difference of squares. X plus 3, x minus 3. And bring down the 4. Alright, so this is fully factored. Let's factor this one. This looks like it has a GCF of 6. So then that'll give you x squared plus 6x plus 9. Then factor this. Alright, do the x. Alright, basically you'll end up with x plus 3. X plus 3. Alright, and then a 6. Okay, now when you're finding the LCM, least common multiple, so if you have normal numbers, look at the normal numbers first. So let's say you have a 4 and a 6, alright, what would the common denominator be? Alright, meaning, let's say pretend these were fractions, right? And let's say you had a 4 and a 6 here, what would the common denominator be? Alright, so the lowest common denominator in this case we know would be 12, right? And then now the least common multiple needs to have one of each term. So let's take a look at the x, the x plus 3 here. So over here for x plus 3 there's one of them. Over here for x plus 3 there's 2 of them. So you want to keep the higher exponent. Alright, this is really like x plus 3 squared, right? You want to keep the higher exponent. So for our LCM, for the x plus 3, alright, they both had an x plus 3, but this one has 2 of them, so you want to keep the higher exponent. Okay, the higher exponent. Right. And then x minus 3, right? X minus 3. Now even though this doesn't have an x minus 3, right, it doesn't matter. When you're finding the LCM, the least common multiple, you need to have at least one of each different factor, right, or each different term, right? So the 4 and the 6, so when they're normal numbers, just treat them kind of like fractions, right, like normal numbers on the bottom of fractions. 4 and 6, well, common denominator for 4 and 6 would be 12. Then these binomials, alright, x plus 3, this one had 2 of them, you want to keep the higher exponent. And x minus 3, even though this doesn't have one, it doesn't matter because you need to have one of each term. So our LCM in this case, alright, would be this right here. Okay? Now, LCM is very important because if your LCM is wrong, everything else you do in the problem later is going to be incorrect. So the most important step is understanding how to find the LCM correctly. Because if you do this wrong, it doesn't matter what else you do. The rest of the problem is going to be incorrect. Okay? Let's practice LCM a little bit more. So let's take a look at these additional examples right here. Alright, so let's find the LCM for these right here. So we're going to factor, so over here it looks like we can take out a 3. And then we have x squared minus 3x minus 10. And then over here, so you would do the x to factor this, so it looks like we'll end up with x minus 5, x plus 2. Alright, and then that'll give this. Over here, to take out the GCF, 6, and over the x plus 5. Alright, so our LCM in this case, alright, so we're looking at this right here. So let's take a look at the 3 and the 6. So the least common, alright, is going to be 6. Alright, that would be a common denominator for 3 and 6. And then x minus 5, this one doesn't have an x minus 5, so go ahead and just put x minus 5. X plus 2, this one does have an x plus 2, so put an x plus 2. And then this one has an x plus 5, so we need an x plus 5. Alright. Remember, your LCM has to have one of each different factor, right? Alright, one of each different factor. And if a factor repeats in both terms, you keep the higher exponent. Okay? So this would be our LCM for this example. Let's take a look at over here, B. So over here, let's take out the GCF, which is 5. So that gives you x squared plus 3x plus 2. Factor this using the x, basically you would end up with x plus 2, x plus 1. Over here, take out the GCF, take out the 2. You end up with x squared minus 4. And that's the difference of squares, x plus 2, x minus 2. And then, to find our LCM, alright, 5 and 2, alright, looks like common denominator should be 10. X plus 2, this one has an x plus 2, this one has 1, this one also has 1, so just put 1, okay? So they both have the same amount of terms, which is just 1. X plus 1, you need to have an x plus 1, then x minus 2. Alright, then you're set. So this would be your LCM. Remember, LCM always has to have one of each different factor. If any factors repeat, for example here the x plus 2, you repeat it in both terms, right? Right, if they repeat and if one has more than the other, you keep the higher exponent. In this case, they both only have 1, so you just put down x plus 2 once. So that's how you find the LCM. Let's move on. Alright, so we're going to actually work out a whole problem here. So over here we need to simplify, so we're asked to add, alright, alright, these rational expressions. So we need to find the LCM first, right? So to find the LCM, we need to factor. So over here, let's factor the denominators. Alright, so when you're finding the LCM, you need to factor the denominators. Alright, you don't need to worry about the numerator, just worry about the denominators. So this would be x plus 4, x plus 1. Once again, you would actually be doing the x for all this. I'm just kind of saving time, right? Because you guys should know how to do the x from chapter 5 anyway. Over here, GCF is 3, so x plus 1. So when we're finding our LCM, this has a 3, right? So we've got to have a 3. And then x plus 1, they both share 1x plus 1. So put x plus 1 once, right? Only once. And then also need x plus 4, because we need one of each term. So this is our LCM here. Okay? So what you're going to do next is whatever your LCM is, right? You're going to write it, right? On the bottom of each one of these fractions. Now you're going to compare. So here's your LCM. So this is what you need in order to add these rational expressions. So what does this have that this one does not? So what's missing, right? It looks like this is missing, right? A 3, right? So you're going to multiply, right, by 3 here. So that's what gives you the 3. So whatever you do on the bottom, you got to also do at the top. Alright, so 3 times 1, that'll give you 3. Over here, what's missing? Alright, so we've got the 3, the x plus 1, we're missing the x plus 4. So you've got to multiply this right here by x plus 4, because then that'll give you the missing x plus 4 that you need. So you gotta do the same thing on the top here, x plus 4. So 5x times x gives you 5x squared. 5x times 4 gives you positive 20x. Alright, you've got common denominator, right? Now it's okay to add. So you're going to simplify the top. So the top's going to be 5x squared plus 20x plus 3 over whatever your common denominator is, or LCM, 3 parentheses x plus 1, x plus 4. Right. And then you always want to see if you could factor this right here, right? Because sometimes, I mean, usually, rarely, but sometimes you can factor this, and then once you factor it, there will be a term that'll cancel with the bottom, right? But so always just double check, can you factor this anymore? So 5 times 3, 15, middle term is 20. So are there any numbers that will multiply that will give you 15 and add up to give you 20? No, right? So you can't factor this anymore. So this is your final answer right here. Okay? So basically that's how you add rational expressions. Let's go and try a subtraction problem now. Now subtraction problems is really similar. It's not really very much different. There's one minor difference at the end, but everything else is pretty much the same. So once again, we need to find the LCM. So we need to factor, right? So take out the GCF, 5, and then we end up with y squared minus 25. So basically this is 5 times y plus 5, y minus 5. Alright, difference of squares. Over here, take out the 3, and the y plus 5. So our LCM looks like 5 and 3, so we need 15, right? Y plus 5, y plus 5, so they each share a y plus 5, each have a y plus 5. And then a y minus 5, we need one of those. So once again, you're gonna, whatever the LCM is, y plus 5, y minus 5, 15, y plus 5, y minus 5. Right. So what does this have that this one doesn't? Well, it looks like it has a y minus 5, has a y plus 5. This is 5, but we need it to be 15. So what do you need to multiply this by in order to make it 15? You need to multiply it by 3, right? So we're going to remember this right here eventually became this. So we're multiplying this term over here by 3. Right? Because 3 times 5 will give you the 15, that's what you want. Right? So whatever you do in the bottom, you got to make sure you also do on top. So 3 times 7y gives you 21y. Right here, alright, looks like everything's almost the same. Looks like we need to multiply by a 5. And it looks like we're also missing a y minus 5. A y minus 5. So, let me erase this real quick. This is a 5 and a y minus 5. Right. So this is what we're multiplying top and bottom by. So when you're doing this right here, you multiply the 4 times the 5, that'll give you 20, right? And then just distribute the 20 into this. So 4 times 5 gives you the 20, and then distribute the 20 into these two. So you end up with 20y, right, minus 100. Now the only different thing, right, about a subtraction problem is once you've kind of worked all this stuff out right here, if it's a minus problem, you have to change this sign into a plus, and then when you do that, the top right, this right here, you have to change to the opposite. So this 20y becomes negative now, and this negative 100 becomes positive. So that's the only thing different you have to do when it's a subtraction problem. And then just simplify the top, 21y and negative 20y, that'll leave you with y, right? And then plus 100 over whatever your LCM was, 15, y plus 5, y minus 5. And then this would be your answer. Okay? Next thing, complex fractions. Right. So a complex fraction is basically a fraction problem in the numerator and a fraction problem kind of in the denominator. So you kind of have, basically you have a fraction over a fraction, right? So what you do is you're going to figure out what the top is first. So the top is 1 over x plus 3. So you need to simplify this and figure out what the top is first. So let's put a 1 underneath here. So you need to get common denominator here, right? Well, you need to get an x, right? So the common denominator is going to be x. So over here, that means you need to multiply this by x, top and bottom, right? So over here, you don't need to do anything because this already has an x. So this is already 1. Over here, that'll give you 3x. So when you simplify the top here, the top is going to be basically 1 plus 3x over x. Okay? So you do the same thing on the bottom. So the bottom, we have 5 over y plus 4. So let's put a 1 underneath here. So our common denominator is going to obviously be y. So you need to multiply this right here by y. So this already has a y, you don't need to do anything. So that's just going to be 5, right? 4 times y is 4y. So the bottom right here of the fraction is going to be 5 plus 4y over y. Now when you're dividing, like we talked about before, it's the same thing as multiplying by the reciprocal, right? So this problem is, right, when you're taking 1 plus 3x over x divided by, right, 5 plus 4y over y, right? This is the same thing as multiplying by the reciprocal, so you would flip this, y over 5 plus 4y. This remains the same, 1 plus 3x over x. And then, right, you're just going to multiply everything, so you're taking the y, you're going to distribute it here. You end up with y plus 3xy. Over here, you multiply here, you end up with 5x plus 4xy. Okay? Alright, there aren't any terms to cancel out or anything. Right? Remember, you can't just cancel the y and the y here because this is one whole term. So this will be your final answer right here. Okay? And then that's complex fractions. Basically, you have a fraction over another fraction. The key is to just simplify the top, simplify the bottom, and then remember dividing is the same thing as multiplying by the reciprocal. Okay?